All right, welcome back. So before we get started, remember to like, subscribe, and share it if you want, along with anyone who might be interested in the AWS Security Specialty Exam. We're going to go over some more practice questions, this time from Identity and Access Management. All right, let's go on. Question 2. The company has decided to revamp the security for its IT infrastructure and tighten rules for access to AWS resources across the organization. In this context, a security engineer has been tasked with creating optimal access credentials, permissions for the company's applications to access the required resources. Some of these applications will run on EC2 instances and need cross-account access privileges or resources present in another AWS account. The company also maintains a few mobile applications that need to access AWS resources. As a certified security specialist, which of the following would you recommend as the best practices to configure access credentials for these applications? Select 3. Okay, so your best ones are going to be B, E, and F. So define an IAM role that has an appropriate permissions for the application and launch that Amazon EC2s with this role associated with the instance. Use an IAM role to establish trust between accounts and then grant users in one account limited permissions to access the trusted account. And then use Cognito to manage user identities in your mobile application. You can then use the Cognito credentials provider to manage credentials that your application uses to make requests to access resources on AWS. So why? Okay, so the IAM role for EC2s. So IAM roles provide temporary credentials to EC2s automatically. You don't need to store long-term credentials, so it minimizes risks. And let's see if we can get some supporting. Okay. All right. Temporary credentials with IAM workloads with IAM roles. This is right here in the header. Okay. So AWS delivers the temporary credentials of the IAM role to the compute resources. Boom. That's it right there. Applications written using AWS SDK will discover these temporary credentials to access AWS resources. That whole sentence from top to bottom, that covers it. Use IAM roles for cross-account access via trust relationships. Let's see. Okay. So let's see this. All right. So where would this be? Okay. You don't need to grant okay. So you need to grant cross-account access. So use an IAM role to establish trust between accounts, and then grant users in one account limited permissions to access trusted accounts. Okay. And then Amazon Cognito. Let's see what this says. Oops. All right, let's try and get this. Okay. Okay, so your app exchanges a user pool token with an identity pool for temporary AWS credentials that you can use with the AWS APIs and command line. So there you go. All right, so why the other answer is incorrect? Let's go back to that. Okay, so IAM user access on EC2. So this requires a static long-term key, right? So this increases risk. So AWS recommends using roles instead. Okay. So that's why A is incorrect. And then D, embed access keys. Well, that's not a good one. So embedding credentials in an app, even encrypted, is insecure and violates AWS. All right. All right. So in summary, the correct IAM role for the EC2 and IAM roles for cross-account and Cognito for mobile, right? So let's go to the next one. Okay. So a media company uses S3 to store artifacts that may only be accessible to EC2 instances running in a private VPC. The security team at the company is apprehensive about an attack vector wherein any team member with access to the instance could also set up an EC2 and another VPC to access these artifacts. As a security specialist, which of the following solutions would you recommend to prevent unauthorized access to the artifacts? So this is saying A, configure an S3 VPC endpoint and create an S3 bucket policy to allow access only from this VPC endpoint. So why is this correct? So gateway VPC endpoints for S3 keep traffic on the AWS network, not the public internet. And you can use a bucket policy with a condition like AWS source VPC-E to ensure requests come exclusively from this VPC endpoint. So it blocks other IPs or roles, including malicious instances in other VPCs. So let's go into the support. Okay. Okay. Control access. Let's go in here. Okay, so you can use the bucket policies to control access, specifically from specific endpoints, VPCs, IP addresses, and AWS accounts. This example shows the policy statements that allow the access. This is it. This supports it. All right, and then this shows the gateway endpoints. Let's see. It says private DNS. Let's go back up. Okay. Oops. This shows the same thing, but we can go down here and see it also doing it for the specific VPC, right? Allow access to the VPC, deny, put object, get object, delete object, for example bucket, right? For the source VPC, boom. And then how do you restrict access to a specific IP address, right? And you can see the IP address right here, doing this similar thing. And then you can restrict access to buckets in a specific account. Here's the account right there. All right. So why are the other answers incorrect? Okay, so restrict S3 access via security group and bucket policy. So bucket policies don't accept security group IDs as a principle or condition. So security groups are irrelevant to IAM policies. And then IAM roles, all right? So any EC2, so IAM roles in a restricted bucket to the role, right? So any EC2 with the same role can access S3. It doesn't prevent unauthorized VPCs or instances with that role. So it doesn't protect against the cross VPC misuse. And then the Elastic IP. So you cannot use AWS source IP in a bucket policy for S3 requests made through a VPC endpoint. So S3 ignores source IP conditions when endpoints are used. All right. So in short, you want to go for the VPC endpoint with the bucket policy. So this enforces that only the resources from that VPC endpoint can access the S3. All right, let's go to the next question. All right, security team at an e-commerce company wants to ensure that none of the AWS accounts for its multiple IT teams can delete the AWS KMS keys. Which of the following represents the most operationally efficient solution? So the answer is D, which would be use AWS organizations to set a service control policy that denies the KMS delete and the KMS schedule key deletion actions for all accounts within the organization, right? So cover all the subsidiary accounts as well. So why is this correct, right? So service control policies allow central control over the maximum permissions that can be delegated to IAM identities across member accounts. So service control policy with a deny statement ensures no identity in the member accounts, even the root account, can perform these KMS key deletion actions. All right, and let's go for some supporting documentation. Okay. So SPs do not grant permission to IAM users. No permissions are granted. So let's see. The maximum size, effects on permissions, that might be it. These are similar to IAM, but however, SCP never grants permissions, okay? And let's see if we can get some more information here. Okay, so an SCP defines a permission guardrail or sets of limits on actions that the IAM users and roles in your organization can perform. To grant permissions, the admin must attach policies to the control access, such as identity-based policies that are attached to IAM users and IAM roles, and resource-based policies that are attached to the resources in your accounts. Okay, so the effective permissions are the logical intersection between what is allowed by SCP and resource control policies. All right, so SCPs don't affect users' roles in the management account. They affect only the member accounts in your organization. So this means that SCPs apply to member accounts that are just designated as delegated administrators. All right, and let's see if we can find. Let's go into why the other ones are incorrect. All right, so permissions boundary via organizations. All right. So permissions boundaries apply to users or roles, not to entire accounts. An organization doesn't support setting boundaries centrally. Okay. So AWS only works with service control policy, not permissions boundaries. And those can deny actions organization-wide. So inspector, all right, I know this is wrong. How do you know? Okay, so inspector is designed for vulnerability scanning. It can't monitor or block KMS delete operations. Okay, and then AWS config. Why is this incorrect? So AWS config only detects non-compliance or configuration changes. It can't prevent key deletion. While you can set alerts or even auto-remediate, like cancel scheduled deletion, the initial deletion action would still occur. So config states this, and it's prescriptive guidance pattern, right? So it shows what can be done, and it can remediate certain things with other actions. All right, so remember for this, service control policy denies KMS delete and schedule key deletion. Why? Because it's central, it's account-wide prevention, and it does stop the deletion. Okay? So next question. All right. Security engineers have been asked to create an identity-based policy that allows access to add objects to an S3 bucket, but the access should begin from April 1st, 2023 through April 30th, 2023, inclusive, right? How do you define this policy? So I believe the answer is put object, login time. I think it's this one, B. All right, but let's scroll down and see. Oh, current time. Oh, okay, so it's C. All right, so why is it C? Put object. Okay, so allow put object, the date being greater than, current time. There you go. Okay, put current time of 2024, excuse me, April to April 1st, 30th, 2023. Okay, and that's the condition. Okay, so why is this correct? Okay, so it uses current time and a date-based condition with an identity policy, right? So why does this work? So this is an identity-based policy using date greater than and date less than with current time to allow access within a specific date range, right? So you cannot use policy variables like login time with the date condition operators. Only current time is valid. Excuse me. Okay. And you'll see this here supported here, right? Create or edit multiple conditions. You cannot use a policy variable with the date condition operator. There you go. All right, and then let's see if we have some more supporting documentation here. Nope, same thing. Okay, that's okay. All right, so why are the other ones incorrect? Okay. So using login time, all right, so you'll see that here. So AWS explicitly states you cannot use policy variables with the date condition operators, right? So variables cannot replace date keys, and they only work with the string ARN-based operators. So login time is not valid. All right, so the effect, deny, okay? So a deny inside the date range would block the put object, which is the opposite of the requirement, right? So granting write access during April. So the requirement is to allow, not deny during that date period. And then let's see, including a principal. Okay, I just saw that here. Okay, so documentation will clarify that identity-based policies cannot include a principal. They're attached directly to a user, a group, or a role. So principal is implicit. Okay, so for this, remember that you want to allow this, allow, based on the date with current time, greater than, less than, okay? And this matches AWS's example for time-bound permissions. All right, let's go to the next question. Security engineers have been tasked with the job of configuring access, control, and authentication for the AWS KMS keys of a particular account. Which of the following would you identify as valid points of consideration for configuring the requirement correctly? So it says A and B, so AWS identifies that they AWS identities that have the KMS create key permission can set the initial key policy and give themselves permission to use or manage keys. That's correct. And the IAM identity that creates a KMS key is not considered to be the key owner. Like any other identity, the key creator needs to get permission through a key policy, IAM policy, or grant. I say, why is this correct? Okay, so IAM identities, right? With a KMS create key. So create key permission allows the principal to define the initial key policy, including granting themselves the rights to use or manage the key. This ensures they can control the key from creation onwards. Okay. Okay. So KMS create key is required. Okay. So put the key policy is not required. KMS create key permission includes permissions to set the initial key policy, but you must add this permission to the key policy while creating the KMS key to ensure you can control access to the key. All right. However, principals who have the create key permission can set the initial policy and give themselves permission to use or manage the key. And then, let's see, why is the other one correct? All right. Oops. Okay. So the IAM user who creates a KMS key is not considered to be the key owner, and they don't automatically have permissions to use or manage the key that they created. Like any other principal, the key creator needs to get permissions through a key policy, an IAM policy, or a grant. However, principals who have the KMS create key permission can set the initial key policy and give themselves permission to use or manage the key. Okay, why are the other ones incorrect? Okay, so let's see. So KMS keys belong to the AWS account. All right, so KMS keys belong to the AWS account root user until permission is granted. No, so that's wrong. So by default, no identity, including the root account, has permissions on a new key unless explicitly granted. So KMS enforces explicit permissions only. And then authorization to use KMS keys, authorization given through federated identities or ACLs. Okay, so federated identities relate to authentication, not key permissions. So KMS does not use traditional ACLs. Access must be defined through key policies, IAM policies, or grants, not ACLs or federation alone. And then, let's see, permissions. Okay, so resource-based policies. Okay, so this is describing what a resource-based policy is. This is not specifically about KMS behavior. It doesn't really address how KMS keys or KMS key access control works. So it makes it's a distractor, right? So the 2 points, according to AWS, would be principals with KMS create key control initial policy and can self-authorize. And then key creators have no default rights. They must be granted explicitly, all right? And those are covered in this. All right, so next question. All right. A company is planning to launch a mobile application for its business critical functions. Mobile users should have access to AWS resources without having to define AWS identity for each of them. Guest user access is a necessity for the application. As a security engineer, which of the following would you suggest is the optimal way of configuring the security credentials for mobile users? So create access keys for any IAM user belonging to AWS account that holds the resources needed for the mobile application. Use these access keys to sign programmatic requests with SDKs for mobile development. Okay, so why is this correct? Okay, so for mobile applications, AWS recommends Cognito, right? So Cognito supports authenticated access, and it doesn't specifically say this, right? Oh, I'm sorry, it's this one. Sorry. So Cognito, right? And Cognito supports unauthenticated guest access, right? So federated identity management, and it provides temporary AWS credentials without embedding long-term credentials in the mobile applications. Okay, so why is this a good fit? I think we've gone over this a little bit. Okay. For Cognito. Okay, Cognito lets you add user sign up, sign in, and access control to your web and mobile applications quickly and easily. Cognito scales to millions of users and supports sign in with social identity providers like Facebook, Google, Amazon, and enterprise identity providers like SAML 2.0. Right? That's a perfect one. Okay. And then let's see. It's also got integrated authentication and credentials management. So Cognito combines authentication, enables mobile applications to securely access AWS, and it's simplified, right? It's a simple thing to do, right? Because it has mobile applications to handle it handles user identities through mobile applications, especially when guest access is permitted. All right. All right. So let's continue. Why are the other ones incorrect? Okay. So create access keys for IAM users. Okay, so this is long-term credentials in the mobile application. So this is a major security vulnerability. So AWS recommends temporary credentials from IAM roles, which Cognito does. Um, let's see, use AWS security token service. Okay, so while STS, security token service, issues temporary tokens, it only handles authorization, not authentication or user management. You need to build your own authentication layer from scratch. And Cognito handles both authentication through user pools and external IDPs and STS-based credential issuance with much less effort, right? And then finally, oops, ACLs. All right, so ACLs with SCKs, this is not relevant to user identity. ACLs for S3 object permissions and can't manage credentials or identities. So they don't provide identity or credential management for any mobile application, right? So your best answer is going to be B, right? Why? Because Cognito has temporary credentials via identity pools and STS, then guest access, right? Via those identity pools with the guest access. Then has authentication support via the user pools or the external IDPs, and it has least privilege and scalable access, right? So it's managed via IAM roles and policies. Okay, so remember to use Cognito to manage both public and authenticated users and attach appropriate IAM roles via identity pools. So this grants secure, temporary, least privilege credentials without embedding or sharing permanent keys. All right, next one. Next question. Okay, so a rapidly growing e-commerce company stores all of its sensitive customer data in an S3 bucket. To ensure the safety and security of the data, the company has chosen to encrypt it using a key management service, customer managed key. The company also uses Lambda functions to perform various tasks with the same account as the S3 bucket. The Lambda functions need to access the data in the S3, but the company must ensure that each Lambda function has its own programmatic access control permissions to use the KMS key. Which of the following do you recommend? And so this says D, establish a Lambda execution role that provides access to the KMS key for each Lambda function. That makes sense off the bat. Okay, so why is that? So Lambda functions access other AWS services like KMS using a role that they assume at runtime. And so assigning each function its own execution role allows you to scope KMS permissions precisely for each function. Okay, let's go to the documentation. Okay. So lambda functions execution role is an identity role that grants a function permission to access AWS services and resources. Boom. So you might want to create an execution role that's permissions to send logs to CloudWatch and upload trace data in X-Ray. So you can continue and find out how to create, how to manage the role with the CLI, how to grant least privilege. This covers it. Okay. So the role must include the KMS permissions like KMS encrypt and decrypt. So that means to write the encryption, and then decrypt is to read the encrypted information, right? So you can do that either via IAM policy or if necessary via KMS key policy or grant, right? And to decrypt, remember, to decrypt any data, you need that decrypt, okay? That's for data, environment variables, or anything else encrypted with the key, okay? So let's go back to why these are incorrect. Okay, so assign an IAM policy. Okay. So you can't directly attach IAM policies to Lambda functions, not to the functions themselves. Permissions must be granted to the function's execution role. Okay. And then create a key grant for the Lambda service principal. Okay. So KMS grants are indeed for temporary or service-based access, but you can only create a grant for an IAM principal, like roles or users, not for the service principals, like lambda.amazonaws.com. Okay. And then set up each Lambda function to assume an IAM role that grants access to the KMS key, the managed KMS key for S3. Okay, so AWS managed keys cannot be customized. So you can't grant access to them. Remember, customer managed key, all right, versus AWS managed KMS key, okay? So they can't be customized. So AWS managed KMS keys cannot be customized, right? So you can't grant access to them via role assumption. They have fixed key policies managed by AWS, and roles in your account cannot modify or assume them. Okay, so bottom line, assign each Lambda function its own execution role that includes KMS permissions, aligning with best practices recommended by AWS for least privilege and proper service access. Okay, and then let's see, next question. A security engineer has been tasked to evaluate the outcome of different policies, including but not limited to identity-based policies, resource-based policies, IAM permissions, boundaries, sessions policies, and AWS organization service control policies of an AWS account, which are the following valid statements regarding the aforementioned policy evaluations. So this is saying A, if no applicable allow statement is found in the service control policies, the request is explicitly denied, even if the denial is implicit. That's true. If a resource-based policy grants permissions directly to the IAM user or the session principal that is making the request, then an implicit deny in an identity-based policy, a permissions boundary, or sessions policy does not impact the final decision, okay? And in a resource-based policy that grants permissions to an IAM role arm are limited by an implicit deny in a permissions boundary or sessions policy. Okay, that's a lot, right? So why is this correct? Okay, so service control policies define maximum permissions boundaries. If an action isn't explicitly allowed by the SCP, it's effectively denied. When a resource policy, oops, when a resource-based policy grants to the exact IAM user or current session ARN, the other implicit denies don't block it. So in contrast to user principles, resource-based grants to role ARNs are still constrained by permission boundaries or sessions policies. Okay, let's go into some documentation just so we can back this up. Okay. Okay, so let's see. Maximum. Maybe. Okay, so these maximum permissions. Okay, so permissions boundaries in advanced feature that lets you select the maximum permissions that an identity-based policy can grant to an IAM entity. Well, that's not exactly what I want. Let's see. Permission. Okay. The resulting permissions are the intersection of the two. But it's not quite. Okay, so this is going to talk around it a little bit. Just going to give you multiple examples. Okay, so shows identity and permissions, resource-based permissions when they're attached, right? So AWS evaluates all the permissions granted, and then the resulting permissions, the unions of the permissions of these identity or access or resource-based. Okay, so it looks for the permissions boundary of the user, resulting in permissions. So when you add a permission boundary to a user with existing policies, you might reduce the actions that the user can perform. So that shows that it has to be there has to be some more permissions added to this. Okay, so let's see if we can find. All right, and so an explicit deny in either of these policies overrides the allow. Okay, that's one. So an action must be allowed by all policies, meaning identity, resource, and service control policies or resource control policies, right? Must be allowed by all three types. An explicit deny is in the identity-based policy, an SCP or RCP overrides the allow. That's interesting, isn't it? Okay. This isn't quite what I was looking for, but that's okay. And then what is a resource-based policy? Let's see. Let's see if we can find this in here. Okay, so this can change this. So the effective permissions for an entity are, and for an entity are the permissions that are granted by all policies that affect the user or role. So permissions for an entity can be affected by identity-based policies, resource-based policies, permissions boundaries, or service control policies, or session policies, right? So if any of these policies explicitly denies, then the request is denied. So the permissions granted by multiple permissions are more complex, right? So you have to grant these permissions, right? So when a resource-based policy grants to the IAM, to the exact IAM user or current session ARN, other implicit denies don't block it. Okay, let's see if we can find. All right. Okay, so elements with a deny effect will always deny. With a deny effect will always deny. Okay, and then let's see if we can go. So an explicit deny in either of these policies overrides the allow. Okay, so implicit denies in identity, permissions, boundary, or sessions policies don't affect this. Okay, so it's very tricky stuff to go into, but it gives you like a good overview of it. Okay, and then we'll see resource-based policies. Okay, so resource-based policies that grant permissions to an ARN are limited by an implicit deny in permissions, boundary, or sessions policy. Okay, so in contrast to user policies, resource-based grants to role ARNs are still constrained by permissions, boundaries, or sessions policies. And so the role-based grants are limited by these boundaries. Okay, so we covered these, and why are the other ones incorrect? Okay. Okay, so B. So B, D, and E. Okay. Where am I looking at? D, D, E. Yeah, okay, so let's see, an implicit deny in the identity or policy boundary, right? So when resource-based policies target the exact user session ARN, implicit denies in other policies do not override it because it would be in others, right? And other policies. Okay, and then if no explicit allow in the service control policy, the request is implicitly allowed. That's not correct. Okay, so service control policies employ an explicit allow model. So everything else is denied if it's not allowed. So it's going to trick you up a little bit. All right. And then resource-based policy grants. Okay. So resource-based policy grants to federated users not limited by boundaries or session policies, right? So this is incorrect because grants to a federated user are subject to implicit denies from permissions, boundaries, or sessions policies. All right, so in summary, okay, so here's the IAM policy evaluation, how you have to look at it, right? Explicit denies of any policy, then service control policies, right? That have to have an explicit allow. And then with resource-based policies, grants to user or session ARNs bypass identity restrictions, but grants to role ARNs are still limited by boundaries or sessions policies. And then there's permissions, boundaries, and sessions policies. So these intersect with identity-based policies. So it's better to have that explicit allow without the deny, okay? And then identity policies need at least one allow. All right, so we'll go to the next question. An e-commerce company recently saw a huge spike in its monthly AWS spend. Upon further investigation, it was found that some developers had accidentally launched RDS instances in unexpected regions. The company has hired you as a certified security specialist to establish best practices around the least privileges for developers and control access to on-prem as well as cloud resources using Active Directory. The company has mandated that you institute a mechanism to control costs by restricting the level of access that developers have to the console without impacting their productivity. The company would also like to allow developers to launch RDS instances only in US East 1 region without limiting access to other services in any region. So how can you help the company achieve the new security mandate while minimizing the operational burden on the system admin team? So it's saying B, configure a SAML-based authentication tied to an IAM role that has the power user access managed policy attached to it. Then attach a customer managed policy that denies access to RDS in any region except US East 1. Okay, so why is this correct? So you want to use federated access via SAML to integrate Active Directory with the console. So this avoids creating IAM users and supports enterprise authorization workflows. Okay, so Okay. Okay, so we'll go in here. So this will verify user's identity and organization, generates a SAML authentication response that asserts the identity of the user, includes attributes about the user, right? And then it specifies how long the console session and the attributes it can pass, right? So it's good for enterprise authorization and what the credentials are, okay? And then let's see. Okay, so power user access. Okay, so power user access is a predefined policy that allows access to all services within it, with the exception of group or user management. And users can work with managed services, but they cannot create IAM users. Okay, so this gives you a little bit of a taste of what this can do, right? So this will talk about, let's go down here. Okay, and then let's see, add a customer managed policy. Okay, global context. Okay. Uh, let's see. Okay, so this is one. This is one on, okay, so let's see this. So condition keys to limit access to specific versions of this. That's for S3. So it's not exactly what we're looking for, but it's close. Let's see what this. So here's one where you can have a principal ARN, so you can limit the permissions only for the root user. Okay, so this would describe that. And then, so you can limit this to trusted identities. Okay, so you can limit access to your trusted identities and expected network locations while granting access to a resource or to a service. So that's much closer. Okay, and then let's see what else. All right, so some services may create regional service principals to identify a particular instance of a service within a region. You can limit access to a resource to a particular instance of the service, right? So that's very close. Let's see what else we have. The policy limits roles like EC2 via the ARN, the source instance ARN. Here's one. You can use this context key to limit access to services within a given set of regions. For example, the following policy this is it, allows a user to view all of the EC2s in the management console. However, it only allows them to make changes to instances in Ireland, right? EU West 1, right? London, EU West 2, or Paris, EU West 3. So you could use this for US East 1, US East 2, whatever. Okay, so that's much more specific. Okay, and then let's see if there's any other. So limit tags. No, that's not quite. So you can see there's multiple ways you can limit the resource actions. Okay. All right. All right. So why are the other ones incorrect? Okay. So using admin access. Where is this? Oh, there we go. Okay, so using admin access instead of power user access. So admin access includes IAM permissions and it exceeds least privilege. So you could do it, but it's a security condition. Okay, so IAM users per developer with power user access. So this forces manual management and it undermines the Active Directory based single sign-on and raises operational burden, right? So that's a big problem. And then let's see, a service catalog. Isn't that it? Yeah, so service catalog. This is really restrictive. So it limits developers to only service catalog functionality and blocks general workflow. All right. So in summary, SAML-based authentication tied to a power user access role enhances with a region limited RDS policy. So you could use AWS requested region to fulfill the requirements, right? So this would enforce least privilege, limit RDS usage to only US East 1, and then integrate with Active Directory and streamline operations without extra IAM or admin user overhead. Okay, so let's go to the next question. An AWS root user has logged into the AWS account and realizes there is no access to an S3 bucket under the given account. What's the reason for the behavior and how you fix it? So C and E, to modify the bucket policy to allow root user access from the S3 console or the CLI. And then if there's a bucket policy on the S3 that doesn't specify the AWS account root user as a principal, the root user is denied access to the bucket. Okay, so why is this correct? Okay, so AWS states that even the account root user can be blocked from accessing an S3 bucket if the bucket policy does not list it as a principal. Okay, so you have to have the wildcard, that's one, and then signed in, right? You might have to have an IAM user with full access. IAM user assigns a bucket policy to S3 and doesn't specify the root user as principal, the root user is denied access to that bucket. Boom. So you have to have that. That would be the account and root, okay? And then to regain access, you must update the bucket policy to include the root ARN as the principal, which is shown. And so this ensures that the root is explicitly granted access. Okay. So why are the other questions incorrect? All right. So only IAM user with full IAM access. Okay, so this isn't true. Okay, so this is saying only an IAM user with full access IAM and S3 can add the root user. So the root user always has authority to edit policies and buckets access directly, regardless of IAM users. Okay, the root user access keys expired. Okay, so root principals use IAM policies and bucket policies, not access keys. Okay, so to control access to S3 via the console or CLI, expired keys don't prevent metadata level access. Oh, sorry, that would be D. And the root user inherently has full permissions to the account ownership. No, so the root account owns all resources. And so a restrictive bucket policy can override permissions. Remember that explicit deny, that can be in there. And the implicit deny can be there, even for the root, right? So it can result in an access denied until the policy is adjusted, which root user can do. So you don't need to contact AWS support to do that, but it just won't explicitly allow. So you need to do that, right? So to remember this, you need to modify the bucket policy, which the root user can do, and explicitly allow access. And then the root user can be implicitly blocked if it's not specified, right? So that means you have to be specific about it. So remember here's a takeaway, right? The bucket policy omits the root principal, which effectively blocks the root from accessing the bucket. But the root can resolve this. You amend the policy to explicitly permit access to root user ARNs, or you can alternatively remove or correct the restrictive policy. All right, let's go for the next question. Video processing application using a Lambda function to create image thumbnails from larger images. The Lambda function needs read-write access to S3 buckets configured in the same account. What's the most efficient solution to provide the necessary access permissions to the AWS Lambda function? So saying C, create an IAM role for the Lambda function that also grants access to the bucket. Configure the IAM role as a Lambda function execution role. And verify the S3 bucket policy doesn't explicitly deny access to your Lambda function or its execution role. So why is this correct? Okay. So this is AWS's recommended method, right? You get fine-grained, least privileged permissions via an IAM role that Lambda assumes at runtime. And then AWS will explicitly do some following. Okay, so here you go. To give Lambda functions, create an IAM role, configure the role for the Lambda execution role, verify the bucket policy doesn't explicitly deny it. This is from AWS itself, okay? So this approach is the most efficient and secure and eliminates unnecessary complexities. Boom. Why are the other ones incorrect? All right, so what are the other ones? So grant permissions on the S3 bucket. Okay. So this suggests that using a bucket policy even in the same account, right? However, bucket policies are kind of redundant here. So within the same account, the IAM roles are sufficient. Okay, so AWS will typically say that a bucket policy isn't needed unless the resource spans accounts. So you can use the IAM role or the bucket policy. Okay, so attach a security group to the Lambda and allow bucket access. So this isn't applicable. So security groups operate at the network or VPC level, not resource level like S3. So and S3 doesn't support security group conditions in bucket policies. Okay. The closest you might get would be private link with a VPC endpoint, and then or a gateway endpoint to S3, right? That would be the closest. So there would be a lot more different configuration than what this is looking for. And then what would this be? Okay. This one, generate an EC2 key pair stored in secrets manager for S3 access. That's irrelevant. Okay, so EC2 key pairs are used for SSH access to EC2s, not for S3 authentication. And so Lambda doesn't use SSH or key pairs to interact with S3. So remember this, you can use the IAM execution rule and an IAM policy. And this is AWS's best practice because it has least privilege and seamless access. Everything else is unnecessary, redundant, or irrelevant, right? So by using a dedicated execution rule with proper permissions and confirming the S3 bucket doesn't explicitly block access, you've got this solved. All right, let's go to the next question. To improve the security of private APIs, a security engineer has been tasked to configure API gateway to use an interface VPC endpoint. The VPC endpoint policy should only allow full access to 2 specific private APIs through the endpoint. Which policy should this be? All right, so you want a VPC endpoint that controls the private APIs. So for VPC, so you want to look for the API invoke, and then you want to find the principal, right, with the star. So API invoke, principal with the star. I believe it's C. Oh, wait. Principal star, API invoke. What's the difference between? Oh, okay. So this is incorrect. The ARN right here is incorrect. That's why. Okay, so it is B. My apologies. Okay, so why is it B? Okay, so the VPC endpoint policy controls the APIs that can be accessed via an interface endpoint, right? So with the execute API invoke, this can be specified under the principal, right? And with the principal with the star, right? And then the correct API resource ARNs right here will allow invocation only on the specified APIs. That's where. Okay. So AWS probably has this documentation here. There you go. Okay. So this is the VPC endpoint with access to 2 APIs. Okay. So this only allows invocation on the specified APIs. The VPC endpoint policy controls which APIs can be accessed via an interface endpoint. The execute API invoke action must be specified, and then the correct API resource ARNs are listed. Boom. Okay, so why are the other ones incorrect? Okay, so we're looking at VPC endpoint. So why is this incorrect? So VPC endpoint right here, this is for managing the endpoint resource, right? Create, delete, whatever. And it doesn't allow control to the API invocation, so it's irrelevant. All right. So the specific ones here. So why is this incorrect? Okay, so this grants access only to GET methods for one API. The requirement is to allow full access to both APIs with all methods, not just GET. So you need a full ARN with a wildcard, right? So it's that wildcard right here, right? And to both APIs. All right. So, okay. So you want to use VPC endpoint policies for the private APIs in the API gateway. And then the other ones are going to only list the specific GET method right here and here. So you can mark those off. So if you have the correct statement with the API invoke on the full API resource ARN, you're precisely enabling full invoke access to those private APIs via the interface VPC endpoint, matching the best practices and documentation. So you're good. All right, next question. Okay. So let's go to the next question. An AWS user is logged into the AWS account, realize there's no access to an S3 bucket under the given account. What is the reason for this behavior? Oh, we've done this. So modify the bucket policy, all right? And if there is a bucket policy, make sure that it doesn't specify the specific AWS root. So the root user might be denied access. Let's keep going and see if we might be repeating this again and again. Yeah, we've done this one as well. Okay. So the Lambda execution role, remember that. What else? SAML-based authentication for power user. That's that. Okay. IAM role for a Lambda function that grants access to the S3. We've done that. And then we've done this as well, right? Resource branch policies, resource-based policies, and then no allow statement. Yeah, explicitly denied. And then IAM for create key, and IAM that creates key is not considered to be a key owner. Yeah, we've done this. Yeah, and we've done this for the specific API. And so we've done this as well. I think, why am I repeating so many of these? In this the S3 bucket, we've done this as well with the current time, right? The resource and put object and allow, done this. I was rushing too much. Lambda execution role, done this. Power user access, we've done this as well. IAM role for the Lambda function, grants access to the S3, we've done that. We just did this as well. We did the create key again. I think we might be wrapped up for this. Yeah, KMS key, organization, delete, and schedule key. Yeah. Yeah, we've done this. We've done this API already. I think we might be wrapped up. We did this, the VPC endpoint, S3. And then, let's see. Meeting companies is S3. Yeah, we just did this. We did that much earlier. And then a company decided to revamp the security, to tighten this for the EC2. Yeah, we did this much earlier too. IAM role for trust between the accounts, Cognito manage, and then the IAM role has sufficient permissions. Yep, we did that. So I think we might be wrapped up. And then Cognito for SDKs for mobile applications. Yep, we did that. So we're done for this section. Okay, so what we're gonna do, we've wrapped up the sections that have covered the most things I needed review on. What we're gonna do is reinforce what I already know, okay? And then we're gonna do those over the next few sessions. But until then, remember to like, share, subscribe. And if you have any comments, drop them in the chat. And I look forward to retaking this test and then helping you when you take it. Thank you. Have a good day.